So, hi everyone. I'm so excited to be right here with you, sharing. Thanks for the invitation, the opportunity to be here with you. Hi, I'm Bonnie. I'm from Guatemala. I want to share a little bit of my journey of deep learning here with you. So first, I want to talk about a little bit of me. I'm a Christian. I love to serve God with all I can do, with all that, for example, with the talks, with my work. So I love to give Him always the glory and the honor. Also, sorry, there is. Also, I work in the innovation lab on Galileo University. I there make some projects with artificial intelligence, with deep learning, other things with education. Also, I give workshops, talks, and all that kind of things. I'm studying computer science on Galileo University too. And I'm really enjoying my deep learning journey. So I want to share it with you. If you want to talk with me later, or if you don't have time, you can find me on my social networks. There is Twitter, Facebook, GitHub, and all that kind of things. Yeah, so let's start with how to dive into deep learning and not get drawn trying. That is the point, don't get drawn. So, well, first, why artificial intelligence? Why machine learning, deep learning? There are some popular names that we are listening now. They are really, really popular today, but they are old concepts. They become years ago. There was just like little concepts, but today they are a reality. How they become a reality? So artificial intelligence is a really broad topic. The scope is really, really broad. So imagine it as an ocean of topics. Inside that ocean is a sea of machine learning. Machine learning is a branch of artificial intelligence. And inside that machine learning sea, there is a pool of deep learning. So that's why you are going to feel like a little bit of a pool style in my slides. So because right now we are going to dive together in the pool of deep learning. So I hope you don't get drawn. That's why I'm trying to help you. So we are going to be, you are going to dive with me. So let's get ready. So how is before they were only concepts, and today they are a reality. They appear in a lot of technologies that we are using today. For example, in our phones. If you go with a trip with your family and take a lot of pictures, later in the night, maybe you will see that Google Photos says you, oh, I have these photos that I know that you went to a trip. If you want, I made a video for you or something like that. How is like if Google Photos knows that which photos are from your trip? Or for example, if you upload a photo on Facebook, it automatically recognizes who is in that picture and suggests you a label of the person that is recognized on the picture. How is like a computer or cell phone can understand what they are looking for if they only understand numbers? The computers only understands ones and zeros, right? So they become a reality because today we have more computational power. For example, the CPUs and the GPUs, they are so advanced today. And also, we have now access to a huge amount of data because, for example, thanks for the internet, the globalization, the social media, the Internet of Things, we have lots and lots of data that are there for public usage. Or, for example, in our companies, we get a lot of data, years of databases on for example, a company that sells things, they have years of data of what they sell, all that kind of things. For example, there is special efforts to build public data sets like the MNIST or ImageNet. ImageNet is a public database with a lot of images labeled for example, a picture of a tiger, and it says, this is a tiger, and all that kind of things. So we can use that kind of public data to train our artificial intelligence. And thanks for big companies, this research is accelerating. For example, Google and Facebook, they are doing a lot of research on this field because they are trying to create tools to, for example, to protect us. For example, Facebook is using a part of the artificial intelligence in their algorithm to protect us from fake accounts or, for example, from terrorism. There is a lot of special things that the big companies are doing with artificial intelligence. Also, NVIDIA, Intel, IBM, and Amazon are trying to build better things for us with the artificial intelligence. So, in a demanding world with tons of information, the ones that can learn and do something with the information that is collected and analyzed has advantages over their competitors. Also, we can bring better applications to our clients. For example, Spotify and Netflix, they suggest you, depending on what you like, not only your friends or something like that, they really know what you like with the content of what you are listening or viewing. For example, I love the playlist that YouTube make me of music. I have like years of nothing doing a playlist manually. They always suggest me music with only the content that I'm listening, and it also suggest me new music that I maybe could like. Or for example, you can dictate words to your phone. For example, in WhatsApp, you can say, "Hello, mom, I'm going with my friends," and the phone understands what are you saying and write it on your message. Or for example, did you try the Gmail responses? They suggest you always 3 responses. They try to analyze what is on the email that they send you and suggest you 3 options that even is maybe more polite than what we can answer. I can only think on okay, and they suggest me a better answer to answer the email. So when implementing deep learning, we are going to forget a little bit about the if and else. So right now, forget them. So because it's not possible to pre-program rules for any situation or data combinations in the real world. There is a lot of different things that could be that we need something else than ifs and else to know what to do with some situation. So here comes deep learning. So deep learning, there is a lot of applications. The most popular ones are, for example, visual recognition, to detect some objects or places or people in a photo, or the speech. I'm going to shut down this. Sorry, okay. So, or speech recognition to recognize words in an audio. So for example, that's why you can dictate to your phone, because it's analyzing the audio and takes from the audio text. This is used by assistants like Siri, Cortana, or the Google Home. There is something that is named natural language processing, that from a text, it tries to understand what is saying in that text. For example, the chatbots use that kind of technology. Did you already try the messenger chatbots? They are using it to give a more efficient experience to their clients. For example, a big company or a little company, they create their chatbots of Messenger, and they pre-program some questions and try to help the user to do some things, like, for example, buy a new pair of shoes or take an order or different kind of things. So the natural language processing analyzes the text and try to understand what is on that text. For example, there is sentiment analysis that is normally used to collect people's opinions about a product or a service. For example, you have a new application or a new feature in your application, and you have a forum of people writing about that feature. And imagine that you have millions and millions of comments. You don't have time to learn to read all the comments. So imagine to have something that is analyzes the emotions in the sentiments in the comments, and you detect that there is a lot of angry comments. So you can go there and see which ones are the ones that are angry, and see, oh, there may be a bug in your new feature of the application. So there is this kind of things that normally a computer can't do. For example, there is my favorite ones that are the generators of new content. For example, images or videos. For example, there is something that is named style transfer, that you give, for example, a picture, a famous painting like the one that is showing there, that is the screen, and transfer the styles, the textures, and mostly the colors of the picture to another. So, for example, there is a photo of me on the Innovation Lab. So I transfer with the styles of the screen to the photo. If you see, the textures on the lines are pretty similar because it's transferring the style. Or there is a lot of projects with generating new content. For example, Deep Dream. If you want to try it, I left you a link there. So Deep Dream uses the internet images to create new piece of art. So that's why you maybe will see a little bit of memes there, because that's the internet dreams. So, or for example, the project Pix to Pix, that does that someone can draw a human face and then tries to construct a possibly reconstruction of the face with colors, shapes, textures. Imagine it working really well. And you can use it, for example, in police detection. For example, a victim can tell the illustrator or the characteristic of the person, and the illustrators try to draw it and then reconstruct a possible viewing of the criminal. There is a lot of applications. So you say, deep learning seems pretty cool, but how I start learning? So the first step is to understand how it behaves. So to start doing that, I recommend you to use APIs. Try some of them. There is a lot. There is a lot of APIs from Google, from Amazon, from IBM, for Microsoft. Two of them that I already tried is, for example, the Google Cloud APIs, like the vision and the speech recognition, or the video intelligence. The video intelligence analyzes the content of all the frames and try to know what is the actions or distinct scenes on the video. For example, there is another API. There is the Watson from IBM. It has different services like the vision recognition or the natural language classifier. But the most important thing when you are learning is that you try the things for yourself. It's not the same just reading the API, just the documentation, and say, oh, I already learned it. No, you have to try it yourself. So each of the steps that I will tell you, try to do this for all the steps. So I encourage you to build little projects to learn, because the best way that you can learn if you do it by yourself. So try to make some little projects. For example, this one is, I made a little project with the facial detection of Google Vision API. So this face detection detects, I send it a photo, and it answers me with a JSON file with all the data in the photo. For example, the position of the eyes, or where is my nose, where is my mouth. So I play with it and try to draw where is all the things on the picture. For example, that face detection also gives you the emotions, the sentiments that the person could have. For example, in that photo, I was happy. So the API detects that, or if I could be sad or something like that. Even that, it can also give you data like if you are wearing a hat or something like that. So first, to try to understand how it behaves, try some of the APIs. Then you will need to start learning you will need to start searching for learning materials. Depending on the project that you are working, you will need to deep dive a little bit more or more superficial. Some projects with an API is enough, but if depending on the problem that you want to solve, you will need to deep a little bit more. So there is a lot of videos, a lot of content in the internet. What I really recommend, if you are interested in learning more, do some courses. For example, the deep learning specialization on Coursera is taught by Andrew Ng. Andrew Ng is one of the most famous researchers on deep learning. For some time he works on Google projects and other kind of things. Another good course that I recommend you is the Deep Learning Annual Degree of Udacity. Or if you want to not follow a course, if you want to just look videos or something like that, there is a channel that is named Siraj Raval. He makes a lot of videos about deep learning. He does a lot of tutorials with coding, examples, all that kind of things. So that may help you a lot to learn. He teaches in a more practical way. So when you are learning, maybe at the beginning could be a little bit confusing. So I want to help you with some basic concepts that will help you to understand about deep learning. So first, artificial neural networks are the learning algorithm that is used on deep learning. In a really, really simplified analogy, it's similar to the biological brain. When we are learning something, for example, a new programming language, first we seek for information. We seek for videos, we seek for lectures, videos, courses on the internet. Then we start practicing, and each time we practice and practice, we do it better. With the neural networks, it's similar. We give them data, and then we try to train it. So the neural network could learn something. So when we have luck, there is some teacher or mentor helping us. They tell us what is wrong and what is right. That is supervised learning. So to a neural network, we give the data and labels to give it feedback of what is correct or what is wrong. For example, we can give it a photo of a dog and tell this is a dog, give another photo of a dog and another one, and try to train it and teach that what is a dog with images. Then try to give new data that he never seems before, and try to guess if the neural network understands what is a dog. So we use data to train it and later we try to use new data to know if the artificial intelligence really learn what we want to learn using new data. There is another type of learning that is named unsupervised learning, that we forget about the labels and only we give data to the neural network. So it has to, by itself, know which is the structure of all the data and separates by groups. That is really useful to find patterns. For example, if you have a group of users that are buying things, and you need to know which are the ones that has more tendency to buy something, you can search for them in all the data and find them. Or for example, if you need to find out the users that are doing some bad things, you can use it to find all what they are doing and try to solve the problem of the users that are doing some bad things. There is another type of learning that is named reinforcement learning. In this, the neural networks interacts with an environment. Not necessarily just images, could be some other variables. And we gave them an objective that they have to accomplish. So with the environment, they should take a decision of what action they will take. So obtaining feedback each time they are more near to their objective. So for example, with this image, there is an image of a game that is named Mario. So we gave the environment and ask, what do you want to do? You can jump, or you can walk, or you can stay idle. So the artificial intelligence watch the environment and take an action. So later we tell you did your objective or not. And if you done, we give it like a reward. Or if not, we tell them that it's not doing their objective. So in a process of trial and error, we'll find which is the best action depending on the environment. And with all the trial and error process, we'll try to do the best way of solve the objective. So for example, the reinforcement learning is really popular to do research in games. So, for example, the last year on the competition of Dota 2, that is a game of Blizzard, OpenAI they made and trained a neural network that was capable of beat all the best players of Dota on that tournament of the last year. And that is even it's like really awesome how could even beat humans in some tasks. So during the rest of the talk, I will be talking about supervised learning. So remember that we will need data and labels. So we are going to become the mentors of the neural network. We are going to teach the neural network how to do the things so it can learn something. So we've seen what is the neural network, but how it works. So we are going to start with the most little thing, that is a neuron. The biological neuron receives a signal from each of its dendrites, then integrates all the signals and passes it through integrates all the signals, and if pass a certain threshold, will propagate the data to through its axon to new neurons. In the artificial neural, it imitates it a little bit. It has inputs, then multiply them with the weights that are the weights are just the numbers. I'm going to talk about the weights later, but multiplies with the weights, sums it, and then apply something that is named an activation function to propagate the data to the next neurons. So for example, the first activation function that was used was the sigmoid function. More recently is used the one that is named ReLU, rectified linear unit, and the enhancements of the ReLU. The ReLU is just a function that if the number that is on the neuron is negative, will become 0, and then propagates it to the next neurons. So if we connect if we concatenate multiple neurons, we will create layers. So there is three types of layers. The input layer, there we are going to give the data to the neural network. There is the hidden layers that process all the data. So process all the information. There could be multiple hidden layers depending how much we need to be more smarter. We will give it more hidden layers to have more neurons to process all the data. There is the output layer. There we receive our data, our results. A possible result from the input data that we give it on the input layer. On that output layer, we will receive all the results. So we have data inputs, process it on the hidden layer, and receive the results on the output layer. If you see on each of the connections of the image, it has a weight. All the connections will be represented with one weight. These values are really important, and I will mention it why later on the talk. So if you look in this neural network, all the neurons on a layer are connected with the next neurons of the next layer. That is a fully connected feed-forward neural network. So the computers only understand numbers, so we can represent objects of the real world like numbers. For example, we can take a picture and get all the pixels and convert it like numbers. Or for example, we need to represent some object with characteristics. There is a lot of ways that we can represent the objects of the real world like numbers. And then we will label it. For example, with that image, we say, well, this data, the image, is a cat, and this other data that is an image will be a dog. So on the input layer, we represent the objects with numbers. For example, we are going to try to represent a dog with just characteristics. So, for example, the amount of legs that this dog will have will be 4. Or if it has or not has fur, so if it has furs with a 1, or if it doesn't have fur with a 0. Because this is a dog, it will have fur. Or, for example, if the ears are long. If they are long, we can also say 1. If they are not long, we can also say 0. Or even the inches that the ears could have. Then, on the output layer, we will receive that data. And, for example, if we are doing classification, we will assign each of the neurons to represent different things, different labels. For example, on this example, the first neuron will represent dogs, and the second neuron will represent humans. So we will give, I told you about the labels. The labels will be the data that we think should be the true output from the input that we are using. So for example, for 4 legs, has fur and has long ears, we will tell that it's a dog. So the first neuron will have a 1, and the second neuron will have a 0. There are really different ways that we can represent the labels. In this case, because it's classification, I'm going to tell you that will be a dog. So the first neuron should be 1, and the second neuron should be 0. So then we compare the results of our neural network with the label by subtracting from the label the results on our neural network. So, for example, this example was an error of 0.3 on the first neuron and an error of less 0.3 on the second neuron. That error is what we want to reduce because we want our neural network to do the mistake. So we need to reduce this kind of error. The process of giving data, process the data, and getting an output is named feed forward. So we are going to propagate the data from the input layer through the hidden layers to the output layer. So now we know how much error we have, but we want to fix it, right? So we want to minimize the error, not only for one neuron, we want to minimize for all the neurons. So to represent all the error of all the neurons, we are going to use a function called cost that will represent all the error, the global error on all our neurons. So we want to find the minimum of that function. For that, we are going to use something named gradient descent. With a negative gradient, we can find the path to go down that function to try to solve and get the minimum error on that function. For example, if you watch here on the images, if the error goes down in the 3D image, the line in the next image, the lines are approaching the dots. Or the gradient descent is, for example, if you throw a ball in a mountain, it will go down in the most quickest way to go down. That is the concept behind the gradient descent. We are going to find the best way to go down in our error function. So we already calculated, but we need to fix it, right? So to fix it, did you remember about the weights? That are the numbers that we are going to be changing. Each time that we know that we have to correct something, that we need to fix it, we are going to update the weights. So it's like the costs say to the, so we will fix the weights from the last layer through all the layers until the first layer, until the first sets of weights. So it's like the cost is saying to the to the last layer, hey guys, we need to fix this. So the layer will fix the weights, will change it, will update the data, and then tell to the next layer, hey guys, we need to fix this too. So they told to the next layer, they fix until they go to the first layer, updating all the weights. So during the training, we perform feed-forward and back propagation with each of our pairs of data and labels until we find the minimum error. Each time we input data, propagated and updated weights, we will make the error to be lower and smaller. So we need to repeat this until we get a minimum error. So each of the steps that we are going to downside our error, the speed is the learning rate controls the speed at which the neural networks will learn. So you say, oh, if I have a really big number of learning rate, it could learn really fast, but that is not so true. If you use a number that is really big, the neural network will get lost and will never find the minimum error. So that is named overshooting. So you think, oh, I'm going to use a really little number for learning rates, so my neural network could be so accurate. But if you do that, it will take so much time for the neural network to find the error, and you will need lots and lots of more data to solve it. So you need to find a balance of which type of learning rate you are going to use. A really good start is 0.01, and then go down, finding the next learning rate that will fit for your neural network. When you are training neural networks, is really an experimental process. When you try something, if it's not working, you try another thing, and all that kind of things. So there is a lot of papers that suggest you which kind of numbers you should start, but always you will need to search a little bit of which numbers will fit better the neural network that you are training. So remember, we have our data and labels. We have pairs of data and labels, and a lot of them, a lot of data and labels. So we'll make feed-forward and back propagation with each of our pairs of data and labels. So it called one epoch if we pass with all our data. So one pass to all our data and labels, we'll call it an epoch. So we want to minimize the error. So we can do many epochs to become really more smaller error. So you could think, oh, let's do a lot of epochs and again and again and again to reduce the error. But that is not so good, because if you do a lot of epochs, a lot of back propagation and feed forward with the same data, the neural network will get used to the data. So when you bring new data, it will get lost. It's like, okay, I will give you a photo of a dog, and this is a dog. And you give it the same photo of the dog, and another photo that is the same photo. So when you bring a new photo, the neural network will be like, oh, come on, I don't know what to do with this thing. You tell me that this is a dog, so I don't know what is this. So you don't have to do a lot of feedbacks because the neural network will get used to the same data and will not be able to guess with new data. So I was talking a lot of data, that you need data, all that kind of thing. So first, you will need to prepare the data. So to prepare the data, you first need to select the data. So for example, you are going to get the data for the database of your company with years of data. Or for example, you are going to download a lot of pictures from the internet. Or maybe you are solving a new kind of problem. So you will need to generate new kinds of data. For example, you can make an application for mobile or of web application to try to create all the data. For example, if you need pictures of your friends, you can make an application on the mobile and send it to all your friends, and they told them, hey, please guys, take a picture with my application, so you can create new data. So now that you select the data that you are going to use, that you are going to analyze, you need to pre-process the data for the neural network, because the neural networks, as I tell you, they only understand numbers. So maybe you have in your database data that is words. For example, a grocery store that sells pizza, hamburgers, or a restaurant. You can represent all these kind of things with numbers. So you will represent all the data that you are using with numbers. For example, in an image, we can get the pixels of the image, red, green, and blue. But in the image, there is more data that you will not use. For example, the header, the size of the image, the amount of bytes. That is data that will not help to your neural network. So you have to pre-process the data that you are going to use. So continuing with the example of the image with the pixels, red, green, and blue, now we need to transform the data because we are going to help our neural network to understand better the data. So one of the data transformation techniques is named normalization. So for example, with the red, green, and blue, we know with web development or mobile development that the red, green, and blue goes, there are numbers between 0 and 255, right? So we are going to divide the three values with 255. So now the data will change between 0 and 1. So if you see the picture, if really different, if the data changed between 0 and 255, or just change between 1 and 0. So that will help your neural network to find a better way to understand the data. So you need to transform the data to become easier to your neural network to learn. And you need to take care about your data distribution. So for example, you have on your training a lot of images that are for example, with these dogs that are all with the same colors or the same races, breedings. And then in the real world, on production, you are using another kind of things, another kind of images of dogs. Your neural network will not understand really well what we have to do in the production. So you have to take care of collecting data that will be really similar to the data that will be used in real life on your production project. And when the neural network has too few hidden layers, they are named shallow nets or simple neural networks. if you use a lot of hidden layers, it will grow and will be able to solve more complex problems. So because it's going to have more neurons to analyze the data and try to solve complex things. If the neural network has 3 or 4 hidden layers, it will be considered now a deep learning neural network. So that is the name, deep learning, because if you add more hidden layers, will be a deeper learning for the neural network. So that is why the name. So you tell me, oh, come on, stop. You have talking a lot about techie things. So I'm going to stop right now with the basic concepts. So maybe at the beginning, it's a little bit difficult to understand the concepts. So for that, I recommend you, well, the third step is to try to do your own simple neural network from scratch. Avoid using frameworks or libraries. Try to do it with just normal code, and try to create your simple neural network, the part of the feed-forward, the backpropagation, that will really help you to understand how it works, the neural networks. So there is a lot of mathematical concepts, but when you get into the code, it will be really more easy than with the pure math. So with the coding, you will be more comfortable trying to understand how the neural networks work. And you could use most of the languages, programming languages, to try to build your neural network. The first time that I was trying to learn deep learning, I was using JavaScript, because JavaScript is my favorite language. I also know Python, Java, C, but I was more comfortable doing the things on JavaScript. So I tried my first steps doing in JavaScript. Normally, Python is the language that is most normally used because it has a lot of libraries to use maths with. So normally you will see a lot of examples on Python, but do it on your favorite language to try to make your own simple neural network to become more easy to understand all the concepts behind the neural networks. Now, try already trained models. There is a lot of already trained models on the internet. You can search, for example, on GitHub, neural networks that are already trained, and you could try it. So you can learn by example, by other people that already trained their own models, how they build it, how many neurons they use, which number of learning rate they use, and all that kind of things. And as I say at the beginning of the talk, you should do projects to try to understand what are you doing. So for example, this is a project that I made for the Innovation Lab. That is a style transfer project. I use a already trained model and tried to build a front end and a back end use. So for example, I was using a mobile app that takes the picture of the people or something else, a mobile app that takes the picture, then send it to my Node.js backend, and the Node.js tells another framework to analyze the photo and transfer a style from a famous painting to the photo. For example, in this project, I use Tensorflow. So Tensorflow is a framework from Google. So I have a lot of pre-trained paintings, for example, the Scream, the Wave, Rain Princess, and transferred the styles on the photo to the new photos that was taken with the pictures with the phone, with the mobile app. So the next step, use some libraries and frameworks. There is a lot of frameworks that will help you to do some really simplified neural networks that you don't have to go so deeper with the knowledge, because the frameworks will help you to write more easily the neural networks, train them more easy, and it will help to it will facilitate you the implementation and the optimization of your neural networks. There is some frameworks, for example, Keras or H2O AI, that are really user-friendly, really developer-friendly. They are more like concatenating just the layers and just telling which type of activation function to use, all that kind of things, and just train it with the data. There is another kind another kind of tools, for example, the libraries, that you will need a little bit more of knowledge about deep learning and all the concepts, for example, TensorFlow or PyTorch. PyTorch 1.0 was recently announced by Facebook on the F8 event. PyTorch is really useful because when you are developing it and writing your code, it's really user-friendly. And then in production, is using Caffe2 to enhance your project on production. And you tell me, I want to use artificial intelligence, deep learning, neural networks in my browser, or maybe in my phone. Well, that is really possible. For example, if you have a neural network that is not so heavy, and you don't want to have a backend service because it's just a little thing that you want to have it on, you can do it on your browser. So, for example, there is TensorFlow JS that you can use. You can also train the neural network in your browser. So, for example, if you want to be better and better the neural network, when the users come with the neural network and try to use it, we'll train more and more the neural network. Or with TensorFlow JS, you can train it with a lot of data in your computer, and later just use the weights, the values that we was updating, upload it to the browser, to the web page that you are building. I use TensorFlow JS with the already trained weights. So, for example, this is a little bit of projects that are demos from TensorFlow JS. For example, the left one is a neural network that finds in the image. Well, there is a lot of image, like a video. Finds the key points of your neural parts for example, of your elbows, of your hands, of your shoulders. Or, for example, there is another project that I really love it a lot. That is a Pac-Man that you can teach with photos which photo will represent each of the controls. For example, going up, down, left, or right. I try to teach the neural network with my hands. For example, with this sign of my hand will be right control, left control, up control, down control. So take a lot of pictures, then train the neural network, and try to play with that kind of controls. So I was trying to play with that, so like telling them go right, go left, go up, go down. And there is a lot of things that you can do with that thing, with the TensorFlow JS. You can access the web camera, like with this thing. And it's not only necessarily to use images. You can use text. You can use data from your database, lots of numbers that you have about years of data of your company. So there is a lot of other models that are really useful. For example, the convolutional neural networks. This kind of model is used for images that are, for example, rotated or in different positions of the image. And for the neural network, doesn't matter. So these are really, really useful when you are analyzing images. There is another model that is named recurrent neural network. This one keeps a state of what it is analyzing. So this is normally used to analyze text and know what is the context and what is the significance of the words in that text. There is another model that is one of my favorites, the generative adversarial networks, that are the ones that are able to create new content. For example, there is a really peculiar arithmetics with this kind of neural networks. For example, if you have a draw of a face of a cat and you add the body of a pig, but you quit out the face of the pig, you will get a whole cat. Or for example, if you had a lot of pictures of men with sunglasses, and you subtract with a lot of images of men, and then add a lot of images of women, you will get woman with sunglasses. That is really, really strange about the generative adversarials. And the generative adversarials are really useful to generate new content. For example, they are doing experiments to generate text, to generate videos, to generate music even. Or for example, with the self-driving cars, there is really difficult to obtain photos of foggy environments. So they are using the generative adversarial to generate images with foggy environments to teach the neural networks of the self-driving cars what to do when the environment is foggy. And there is a lot of super cool projects that you could go to Google and search it, but there is a lot that I really love it. For example, the auto draw of Google that recognizes an object when you are drawing it. With each of the strokes that you draw, it's trying to guess which of the possible drawing are you doing. So for example, there is a dolphin. With each of the strokes tries to guess what would be the image that you are doing, and just suggests you in the upper hand, and when you select it, change the image for the draw that it thinks that you are drawing. There is a lot of projects that is doing DeepMind. DeepMind, they have not a lot of research in a lot of fields. For example, medicine, politics, games. They always try to do research to build artificial intelligence that have a positive impact on society. There is some experiments to try to guess if there is in a photo the people have a tumor or if the people has cancer with just the photo. Or for example, there is an experiment that I really love it of DeepMind, that this is they build a 3D model environment and a human body. This one is with reinforcement learning. So they tell the neural network, you have to go from the point A to the point B, and this is your environment. So like I told you with the reinforcement learning, the neural network was trying to go from point A to point B. And with the time, trying and error, it starts learning how to walk and even how to avoid obstacles or jump spaces. And everything that can be done with deep learning is amazing. You can create whole solutions with the deep learning or enhance interfaces, user interfaces to enhance the experience of your clients, of your users. For example, there is handwriting recognition that you can write and recognizes letters that your client is writing. Or for example, speech recognition, chatbots, or assistants. So there is a lot that you can do with deep learning. So I hope that I was able to share with you the hype of deep learning, and you don't get drawn with me diving in the pool of deep learning. So thanks for listening to me, and have a happy learning.
And now we're going to take some questions. What kind of data did you use to train the style transfer network that you showed earlier?
As I mentioned before, I use already pre-trained model. That is the doing by example that I was saying. So that one was already trained. And when they do that project, there was just one. There is just one painting, and with that one, it's not the supervised learning itself, because they only use one picture, and try to use that with a combination, like a convolution, with the matrix of the data of the painting on the other photo, and then with the convolution of those of both images, create a new image. So I don't train it myself. That's why that is the example of learn by example with a already pre-trained model.
I have two questions. First, with the epics, you said you don't want to do them again and again because it will overfit. But would you want to do several epics on different, basically, test sets?
Yeah, you have data. So you have to separate your data for training, data for validation, and data for testing. So your data for testing, you will never touch it, because you will use it to know if your neural network already learned. So with the training data, you will use it to try the different combinations of, for example, your learning rate, the amount of neurons, all of that kind of things, and try to validate it with the validation training set. So with that validation training set, you know if the neural network is doing it well. If not, you will try again to train it with the training set with different values of learning rate, different values of amount of neurons. And when you feel that it's already training well the neural network, you will use the test data to know with new data that never sees before, to know if it really learns. If you need more data, there is some techniques to generate more data with your training. For example, if you are using images, and you are using convolutional neural networks, for the convolutional, they don't matter if the photo is rotating or if the photo of the object in the photo is moved. So some techniques to create more data, for example, are crop parts of the photos or flip the photos to reproduce more data.
Okay, you answered my other question.
Oh, sorry.
That's good.
We have time for 2 more questions. Okay, I think that's it. Thank you, Bonnie.
Thank you.